Welcome to this short video presentation on simulating projective augmented reality visualizations in virtual reality. I'm Florian Heinrich, and on behalf of my co-authors, I will try to find answers to the question if virtual reality is a feasible environment for medical AR evaluations. In the medical domain, projector-based augmented reality is an advantageous technique compared to other AR modalities because it leads to less sterility issues and can reduce cognitive demands. The method has different applications and was, for example, used to visualize needle navigation aids. Despite some benefits, projective AR is troubled by high acquisition costs and system setup complexity. It is also difficult to evaluate this method in real clinical settings. In this regard, high-fidelity virtual reality simulations may be an interesting alternative. VR can serve as a controlled and standardized evaluation environment, and it was also already used to simulate optical and video see-through augmented reality output. Therefore, we tried to simulate projective AR in VR and conducted a user study to assess the feasibility of this approach. In this exemplary user study, we recreated a previously conducted experiment. We used projector-based AR techniques to visualize two different needle navigation aids directly on the skin of a phantom. We then implemented the same two methods in virtual reality. For this, we created a virtual twin of our AR lab and used a virtual projector asset to show the needle navigation directly on the phantom. The experiment was then conducted as a between-subject design with two groups, an AR group and a VR group. During the study, each participant inserted 6 optically tracked needles into the phantom, 3 of each visualization. We measured angular and depth accuracy, time, and workload. The procedure and apparatus were the same for both groups. The only difference was that the AR group was guided by real AR and that the VR group was equipped with a spatially registered VR headset. We then calculated the ratio between the cross-visualization trials and the error trials and logarithmized these results. The resulting AR and VR datasets were then compared using t-tests and by calculating Bayes factors. Here you can see violent plots of the logarithmized ratio results for all variables. No significant differences were detected between the AR and the VR group. Instead, Bayes factors showed anecdotal to moderate evidence supporting the null hypothesis that both groups stem from the same population. Based on this, we conclude that VR can be a feasible environment to evaluate medical projective AR visualizations. However, we should be careful when applying these results to other tasks. Future work is needed to replicate similar studies to strengthen our claims. These are the references used in this presentation. And with this, I'd like to thank you for your attention.